Now, an obvious question to ask is, can we go backwards? So let's say we choose a point in R2 specified in x and y coordinates. The x coordinate is 3 and the y coordinate is 2. So to express the point 3, 2, which is given in the standard x and y coordinates, in our new u and v coordinates, we want to solve the equation some number u times our vector with coordinates 1 and minus 1/2 plus some number v times the vector with coordinates 1 and 2 is equal to the vector 3 and 2. We can do this by solving the linear system that is associated with this. So you can see that in uv coordinates, the first one is 8/5 and the second one is 7/5. So if we go back to our xy and uv picture, we start off with a point which we've located using x and y coordinates as 3 units along the x-axis, 2 units parallel to the y, or 2 units along the y-axis, 3 units parallel to the x-axis. Our conversion process simply rotates these axes so that u becomes the horizontal axis and v becomes the vertical axis. Now, we can think about this point as being located by moving 8/5 units along the u-axis, then moving 7/5 units parallel to the v-axis. Now, just as before, we can rephrase this in terms of matrices. So, instead of thinking about solving a linear system using Gaussian elimination, we can actually remember that our matrix defined with columns, the first vector u and the second vector v, because it is a basis, it is an invertible matrix. If we label the matrix with columns given by our basis elements as A, then the solution to our particular matrix equation is x is equal to A inverse multiplied by the vector 3, 2. Now generally, we want to identify this vector x as being tied to our basis. Because we're working in this new coordinate system, we're going to decorate this vector x with a pair of curly braces and a subscript of b. Here, our vector x would have its first coordinate, or its u coordinate, 8/5, and its second, or v coordinate, as 7/5. So this tells us that we have an easy way using matrices and their inverses to convert between our coordinate systems.